Awesome. Thank you. Welcome to the first, I think, Silicon Valley Scale Warrior meetup. We call it the Scale Warrior meetup because all these guys here are pushing the limits of scale when it comes to fast data, big data. And so we want to have, this is the first of what we hope will be more meetups where you guys can sit and exchange war stories. I'd like to introduce our moderator for our panel this evening.
It's always
It's been a long day. It's been a long day. Dave Feinleib. He is author of a soon-to-be published book called Big Data Demystified. And he's also producer of Big Data TV and BigDataLandscape.com. He's also an entrepreneur, founder of SpeechPad, an awesome service that we use, actually, that does audio-video transcription and captioning. And what else have you done? Built a serial entrepreneur, a bunch of companies, bought by HP and EMC, and just a happening guy. So thank you. Welcome, Dave.
Thanks, Monica. Well, it's great to have everyone. So about a year and a half ago, I was training for this event called Ironman France. And an Ironman, for those of you who don't know, is a 2.4-mile swim and a 112-mile bike, followed by a full 26.2-mile marathon. It's a good time. I highly recommend it. Has anyone done a marathon or a 10K or? Okay, so you've all done events like this, and you got like the Garmin GPS watch, and I was, obsessed with my data, and so I was tracking everything about myself, like so many people do, and got really interested in the big data space, started researching it around the same time. A company called Splunk went public, and I thought, gosh, it might be interesting to see how the public market interest in big data companies related to my own personal interest in big data. And so that's kind of how I got into the space after being an enterprise storage guy for a number of years. So we have a really, really great panel tonight to talk about all aspects of big data. We're going to spend about 30 minutes or so with questions that we've all prepared, and then we'll open it up to the audience, and you should feel free to ask away of anything you'd like to know from these guys. So we'll start with intros. Down here on the left, we have Brian from Aerospike.
Hi, I'm a CTO.
Okay, and maybe tell us a little about what Aerospike does and what you do there.
Sure. Aerospike is a distributed database, and we're used very much in the advertising industry for user profile storage and real-time analytics. We specialize in SSD and space in the 1 to 10 terabyte areas. We're here partially because AdTech San Francisco, for those of you who were at the AdTech conference the last few days.
Great. And Steve has been at MetaMarkets for all of 6 weeks now.
6 weeks.
But I expect the full pitch on what the company does. So what does MetaMarkets do, and what do you do there?
Sure. So I'm Vice President of Engineering at MetaMarkets. Just moved over there from Terracotta, where I was for 8.5 years. I was the first engineer on that project, and then got to grow the team, and then eventually be a part of selling that company, which was kind of cool. And then I moved over to MetaMarkets, which is a really exciting transition for me. So what we do is we focus on sort of being able to take all of your data, mostly in the ad tech space right now, but take all of your data, so it's the billions of events that come in around things like ad impressions, revenue, clicks. I'm not from the ad world, so I'm still learning all the nomenclature on the ad side, the click stream. And we end up sort of normalizing it in real time. And so we're sort of real time on the way in, and then also real time in your ability to sort of use pivot tables and visualize and slice and dice your data. So it's sort of got the two sides of real time and the massive amounts of data. And then the other thing that makes it cool is that it's a SaaS. So customers can sort of just connect all these billions and billions of events into our fun little world where we munge it and allow you to do these analytics and pivot tables and graphs and visualizations. Did that make sense? Cool.
That was great. Great. All right. Thanks for the intro. So here we have Scott. Scott spends, a week, a month here, and the rest of your life is in Little Rock. So tell us about your company and what you do.
I live in Little Rock or at the Foster City Marriott hotel, depending on what time of the year. I'm the enterprise architect lead for all the transactional systems at Acxiom Corporation. Acxiom has been a 40-plus year company, traditionally dealing with data analytics and software as a service. A lot in the offline world. We've made a big push in the last year to get in the ad space in the real-time world. Made our public announcement in March. Our DMP is going to be up in full GA in October. We're already in alpha with 2 clients, already taking about 350 million transactions clicks a day. You know.
Great. All right. Well, thanks so much. John, you're with AppLovin, and I got to ask you, where did the name come from?
Well, we were looking at ads on mobile, which is what we do, and we noticed that apps were kind of the key thing that was going on. This is a year or 2 ago. When you went to look at mobile ad domain names or app domain names, everything was taken, but we took our inspiration from the Napoleon Dynamite character, the McLovin character, and we happened to find this domain name, so we ended up with AppLovin. Great. So it's the mobile ad space on iOS and Android. We're an ad network that connects publishers and advertisers, and the key difference on the mobile space is that the data comes through the apps. So apps are kind of the key unit, and there's not really the same equivalent as there is in the web of the cookie and the tying users via cookie. So you have to deal with identities through apps, and that's why we connect with data partners and use big databases and deal with data all the time just to be able to serve better ads on the mobile side.
Great. All right. And GP, down at the end here, you are with Brightroll, and we're one of the co-founders of Aerospike as well.
That's true. Ancient history by now. So I'm a senior staff engineer at Brightroll, and at Brightroll, the senior staff engineers are kind of engineers without portfolio. We work on whatever sort of the most important thing for us to work on at any point in time is. So I've spent the last 6-8 months focusing on sort of our set of problems around real-time data. So Brightroll, depending on the month, is either the first or second largest video ad network in the world. We're sort of neck and neck with Google. As you can imagine, we have an immense amount of data flowing through our system. Some of it we can report on with sort of traditional big data kind of methodologies. Other stuff, in other use cases, we need some way of acting on that data very quickly, and that we would class sort of as a real-time data problem. So that's sort of where I've been spending the majority of my time.
Great. All right, well, maybe we can, on that note, talk a little about the scale of all the different companies. So just out of curiosity, how many people here have technical backgrounds and are heavily technical doing day-to-day engineering? Great. And from the ad world? Okay, good mix. Great. So maybe you can talk about some of the specific technologies that you use and what kind of scale you're at and some of the challenges day-to-day, and we'll start with that from each of our panelists.
You're looking at me,
you on the
so
spot.
I'm assuming you want me to go first.
Yes,
All right.
yes, that'd be great.
So last time I checked, which was about an hour ago, we do on the close order of 16 billion ads a month, which is a reasonably significant amount of traffic. A display ad company would do more, but for video, that's pretty good. As far as specific technologies, so right now we sort of, as I said, break it into 2 parts. There's sort of a historical data reporting part that right now has, for quite a while, been done with internal tools that were written quite a while ago, and we're in the process of transitioning those to a mixture of Hadoop and HBase. For the real-time data projects where you're trying to make a decision about what ad to show someone in that kind of real-time window, 100 millisecond window, it's all code built on top of Aerospike, which has been working pretty well so far.
All right, great. John, what do you do that's kind of unique for mobile apps in particular? What are some of the challenges there?
Well, I mean, I think the stack that I think about is we have a real-time querying component, we have a kind of more batch mode analysis component, and then we have a data warehouse. Maybe the unique thing is the number of profiles that we have. You're dealing with the number of people that have smartphones in the world. So the plan is it's on the order of 2 billion. We're near the billion mark in terms of profiles. So we look at different components of the stack. We use Aerospike for kind of the real-time access to the profile data at the edge. So it's essentially a very good cache tool for us. We'll move data up from the warehouse component into the edge component. I mean, the big trend that we're looking at is, and kind of what GP was saying, is more and more stuff is going real time. You know, our stats are basically 5 minutes off real time right now, and we want to close that gap to be less than a minute. And so that has been the trend for us, is more stuff moves to the edge, more stuff moves in memory, and analysis has to happen in parallel. And I think that'll be a consistent theme for everybody.
Great. Scott, what are some of the technologies you use, and what are some of the challenges for your business?
The differentiator that we're going after in the ad space and the DMP space is taking the offline data that we have. We manage, have probably the top 100 Fortune 500 companies as our clients in the offline, managing their marketing and their offline marketing, bringing that into the online world so that you can get it to other systems that they can make decisions and ads based off of not only the client's data, but also our data assets. So putting that all on the edge and being able to do it in, we've clocked ourselves internally 10 milliseconds to do 2 reads, 1 write to Aerospike. We're using Aerospike as the edge store. Did a bunch of side-by-side comparisons this time last year. They're in the ad space. They're built for the ad space. It was just worked. So that's what we're going to be doing. We're in alpha right now, starting to push data to for a couple different clients, getting that onboarded into Aerospike, and then pushing that out during ad serves and others.
Great. Great. All right. Well, over to this side. I didn't mean to ignore you guys over here. So talk a little about, you're at Terracotta,
Yep.
which is really a big data company, even before big data was a term, I would say. Maybe you could spend a minute and talk about some of the things you learned there, and then you know, a little more about the current things that are going on.
So it was interesting, you know, when we started Terracotta, you know, Terracotta is written in Java, and it was, and you know, a 30 gig customer was a big customer for us. I don't know how many people remember, even probably 4 or 5 years ago, that you could actually say that with a straight face then, and people wouldn't laugh at you and point at you. And then I was talking to a buddy of mine over at Pandora, and he was using Memcache actually, and I said, well, you know, why do you use Memcache? You're a Java shop, and he was saying, well, when you have a lot of data, there's 2 things. One, when you have a lot of data, sure, you can distribute it and you can do it in various kinds of databases. But as far as operations goes, the thing he valued most was predictability. And that really stuck with me. Like, so one of the fundamental things about Terracotta from that sort of, like maybe a year past that when we solved the problem, moving forward, was being able to both scale up and scale out. So, you know, get to that knee in the curve, maybe up to like a terabyte of RAM per machine, and be able to give results extremely predictably and with high availability. And I think the operational character, and the lesson I took away from that is that the operational characteristics of some of these data stores and how they're managed in production and how you achieve 24/7 by 365 by 10 is literally as important or maybe even more important than things like whether it's transactional guarantees versus eventual consistency, and more important than, you know, whether it has every kind of analytic or every kind of search you could possibly do.
And what do you, so you want to make something predictable and, you know, very reliable. What do you do in order to make that a reality?
So, you know, it's interesting. There's a couple things you have to do. One is you have to measure it. The very first thing we had to do is create tests that, in a detailed way, measured, you know, the standard deviations and the predictability, and focus on those latencies. And then in the Java world, for those of you who have experience with garbage collected programming languages, you know, what we did was we built essentially a off-heap store that we could easily scale up to a terabyte. It was would be pre-allocated, and built our own sort of almost our own memory, like So Java, I don't want to get too detailed because I might bore some percentage of the room, but the reason why garbage collection is hard is because you're dealing with graph data, right? Like everything is referencing each other, and you have to figure out what's old and uninteresting. And then there's, of course, the compaction problem. But the observation was, yeah, that's a really hard problem, but it's not really that hard of a problem in a cache, because it's key value, and those keys and values aren't talking to each other. And so we were able to sort of leverage some of the things that existed and this observation to be able to build data stores that scale up to like literally a terabyte per node and more, and billions of entries. And we had already solved a lot of the other hard problems around, having passives or hot standbys and availability problems, because in the 30 gig world, we already needed all that. So I don't know if I answered your question.
You did.
But that was a bunch of random things.
That's great. That's
and then,
great.
I guess on the next step was the Druid side. Sorry, not to monopolize time, but that's in the Druid world, it started out very early on. So by the way, Druid is the open source database that we use, answering the question about what the technology stack is the open source database we use to provide all the analytics for meta markets. And for us, it's literally like each customer is providing us billions of events a day. And I wouldn't say we're up to petabytes yet, but we'll probably get up to petabytes of data, by the end of this year. So it's a lot of data when you're a SaaS. And even for us, it's the same thing. We're very focused on operational characteristics, 95th percentile latencies, or 99th percentile latencies, 24/7 by 365 by 10. So anyway, I don't want to.
Great, that's great. So Brian, you're you started Aerospike along with other folks, of course. What are some of the reasons you felt like you had to build a new database? I mean, we've had lots of databases in the world for a long time. Why build a new one?
That's a great question. Some days I still wonder that myself.
No, it's good. You're fighting the good fight.
Thank you. So I remember the day when GP, since he's got an ops background, he was smoking outside the building. I don't know why all ops guys smoke, but
Quit long ago.
Every week he would say, hey, let's start a company that does X. And one day he finally said, let's actually build a predictable database that stays up under load. And I'm like, you're right, because there isn't one of those. I mean, everyone had to roll their own at that point. And when I left that company, I had 3 different companies call me up. One was the Netflix guys. One was a Kleiner-funded security startup, and the other one was you remember Danger, the hip top, that little cell phone thing.
Oh, yeah,
As a friend of Monica's, from Apple, called me up and said, our servers are in real bad shape. Everything's about to go down horribly, and we're about to lose everyone's email. This was about 2 months before it actually happened. So Andy was actually smart enough, but I didn't say yes to that. But 3 different people called me up the same week, said, come and build an in-house project, build an in-house team to solve server scalability with extreme uptime and predictability. So, I'm not that much of a fool. So that's essentially why, because as you're saying, the hard problem is this predictability. And let me tell you one sort of side story on that. I was at a video server company called Starlight Networks in the early 90s. And this is my second job out of college, and they described the file system for video serving, streaming video serving. And they said, we randomly allocate blocks and scatter them all over the disk. And I was like, that's insane. It's streaming. Why don't you put them all together? And they said, when it's random, then you know that the performance at the beginning, there's no such thing as fragmentation, because it's always perfectly fragmented all the time. You never get the advantage of streaming on disk. So if it's fast enough on day 1, it's fast enough on day 100, it's fast enough 10 years later. So I call this the engineering philosophy of best worst case performance. Engineer for the worst case. Use random techniques, which GP is exploited to a great extent in Aerospike, and make sure that everything's random so that you always get worst case. Then optimize like crazy to make worst case super, super fast. That gets you predictability. And I learned that from a couple of crusty old guys who were old 3Com guys designing this crazy file system.
That's great. So when people talk about big data, they often say Hadoop. And I'm curious what you guys think of that. Is that, should that be synonymous with big data? Is it relevant today? Is it, you know, a key part of what you're doing, or not so much? And feel free to jump in anywhere.
I'll jump in. We've been doing big data before it was named big data, in the batch world, managing all these customer profiles and for all of our large clients. It just happens, the same problems and predictability you have running it in an ETL or our own grid environment, now you're running it in a Hadoop environment. So we're in the migration phase of starting to use off-the-shelf technologies versus what we built ourselves. But it's the same thing, just over again.
Mm. So, I mean, my take is, look, Hadoop gets to name it because they were there first. It's kind of like asteroids or stars or the moon, or not the moon, obviously, but you know, like celestial bodies get named by the first person who sort of gets there. And look, Hadoop is amazing, right? It reduced the cost of managing data by essentially 1,000x, and that it's not that they did something that was so hard or different. It's that they did it well and they did it cheaply and they made it approachable. Somewhat approachable. But it is, I mean, at least to this point, mostly batch oriented. So I mean, we use Hadoop for certain things. You know, when we want to munge a bunch of data and in a batch oriented way, it's probably the cheapest, best way to do so. And the Hadoop name is probably going to keep growing over time and keep pulling in more things. And already Hadoop, what is Hadoop? Well, is it MapReduce? Yeah, that's part of it, but it's kind of, you know, growing to mean a whole ecosystem of things, and you know, they earned that through being first. But it'll be a while, I think. When you start from batch, it's sort of like what you're saying. When you start from batch, it's hard to become the predictable, I think, story. That has to be kind of your goal, I think, up front. It's going to be, I think, a while before they can get to compete with like the Aerospikes of the mid-latencies you're talking about, and that kind of predictability. Yeah, they're trying though. They're trying to get there, but it's actually easier to start from scratch and get to a predictable, big, real-time data store than it is to start from a batch one and convert it into I think anyway.
I mean, one thing I'd say about Hadoop is you have to think about where it came from. We're mostly ad technology people. It's a copy of what Google built in the late 90s, and they had a 5-year technology lead on the other companies that were trying to do similar things. And now Hadoop is actually kind of I think of it as kind of a somewhat mature OS level thing that's the entry level thing for big data. But if you look where Google and the people that the Facebooks of the world are right now, they've passed, kind of what Hadoop with its batch limitation. They're all putting stuff into memory and using massively parallel techniques of different kind of algorithms and compute graphs to be able to do more stuff. So, I mean, that's where, if you're kind of more towards the edge, you have to be more like what there's only a handful of companies in the world really doing that, and there's no off-the-shelf single production system that handles it. But in the meantime, I think Hadoop's great for, kind of enabling mass adoption of this kind of parallel OS for doing computation. So it's a pretty interesting thing, but if you want to follow Google, you have to kind of go where just one story is, if you remember, their indexes used to take a month to update in the circa 2000. If you put a new link on the web, it wouldn't show up in the Google index. Now, if you put a new link on the web, it shows up in 30 seconds or something like that. So that's the difference between kind of batch mode, which their original system was, and then Yahoo's system was, and now what's happening with kind of real-time updating of parallel computation.
Great. Will you spend a minute on video and what some of the unique aspects of video serving and challenges in that area are?
So actually, it's a little bit of a difficult question for me to answer, because from the perspective of a video advertising company, you can make a pretty good argument that if you're going to show a video ad, you're going to it's the same technology as showing a display ad, and we aren't really involved in the data plane so much. I think we would say that's largely been a solved problem by the CDN. So maybe I'll turn the question around and answer the Hadoop question instead. I think that Hadoop has certainly come a really long way from when I first heard about it however many years ago. That was a long time. Anyway, Hadoop remains a a very good tool for, I have an immense amount of data, I want to process it, I want to distill something out of it and deal with it later. I want an absolutely correct result, or as close as I can get to one. I'm totally prepared to wait for it. And there are problems where that is absolutely the correct solution. If I have to write a billing system for example, 16 odd billion ad impressions a month, I'm probably going to use Hadoop, because if it comes out at 1203 versus 1204, I'm all right with the extra minute. Like, that's okay. But if I have some problem where a user just showed up, I have 100 milliseconds to pick which ad they're going to see from which provider, clearly going to Hadoop isn't going to be the right direction. And they are trying, mostly through sort of, let's say, products in the ephemera, like HBase, to try and get that response time down to make their computations turn around quicker. I think they have a long way to go. It is really, really hard to take something that was fundamentally designed for batch processing, where to some degree they have a long history of punting on the hard part of the problem. Like, I vividly remember the day, as Brian alluded to earlier, I've sort of split my career half between operations and half between software engineering. I vividly remember the day, unfortunately I was on the ops side the day I learned this lesson, that the secondary name node really wasn't a backup primary name node so much. So when your primary name node goes down, the entire system stops working for 4 hours as you frantically have techs out trying to swap things around. It's like, I'm glad I wasn't relying on this for the, something that I needed 100 milliseconds ago, 4 hours ago. So I think they're starting to make good progress. They have a long way to go in that space. That's a very hard transition to make. On the other hand, the tree of technology forks all the time. We always come up with different solutions to different problems. The context of the problems we're trying to solve always changes. So, new tools solve new problems.
Great, great. So I'm going to open it up to, oh, please, yeah,
So
go ahead.
what I'm really excited about with Hadoop is what it's done for programmers. Right, so one of the problems with SQL, and one of the reasons why NoSQL started existing, was there are problems, things you can express in SQL which are inherently non-scalable and require single machine. Right, there are certain kinds of large-scale joins which, if you're doing them in a distributed system, they're always going to perform very, very poorly. And what MapReduce did, now not Hadoop per se, but MapReduce, is it's exposed an entire generation now of programmers to the world of, hey, I'm going to do this certain kind of functional programming. I'm going to think of my data as a data stream, and I can only express operations that scale. That's kind of great, and I think that was a lot of the brilliance of the MapReduce programming model. Now, I think we're all going to go beyond there's going to be so many different twists on MapReduce programming, right? Because Tengen and Mongo support it. It's obviously in our future to support some very aggressive and interesting forms of MapReduce on the sub-second basis. But what it's done in terms of programming and programming languages, bringing functional programming at scale to the fore, I think is the brilliance of what Hadoop did.
That's great. So I'd love to open it up to questions from the audience. Before I do that, I do have one question on kind of an entrepreneurial note. So you have all sort of raised money and been out fundraising, starting companies from scratch. Can you spend a moment and just talk about how you went about that, and what some of the memorable moments were? I'm sure there were a great many. But some of the things you've learned from starting your own companies.
I have to be careful here not to embarrass the guy at the other end of the table.
Hey, we raised
That's
money.
why you're on two separate sides of the table, so it's all good.
No,
and I know I didn't. I know we were going to stick to big data, and I didn't prepare you with entrepreneur questions, but I'd love to hear about that.
I'll give my side of the story on the what led to Aerospike. So. Two companies I had worked at in quick succession. So I was the lead engineer on the operations side with three really good coworkers at Salesforce.com. So we took them sort of through their IPO, through about 2 years post. And when I started there, they were on the cover of the Wall Street Journal. It seemed like every other day because they were broken. And we got them off the front page of the Wall Street Journal because of that, which was really good. It was a very hard, very expensive journey because we didn't really have the technology that we needed to make it work the way we knew that it should. So we did things like you attach a document to a case. We're just going to store that as a serialized blob in Oracle. So our Oracle database at the time we left was running on 400 CPUs and 4 terabytes of RAM and probably 16,000 hard drives, circa 2006. And, you know, periodically a node would crash, so Salesforce would be down for 2 hours. So after that, I was really fed up with databases that didn't stay running, databases that cost $100,000 a CPU, and databases that didn't have consistent performance. So I was very, very fed up with that. So I left Salesforce. I wanted to get back into the software engineering side of the world. So I started a little, I joined a little Kleiner Perkins-backed company called Aggregate Knowledge, which at the time we were trying to do behavioral product recommendations. So I was the 4th or 5th employee, something like that. And I was working on the back-end recommendation systems, which was interesting because it was a real-time problem. A user shows up. You can imagine trying to compute something like Amazon style. People who viewed this bought that. You have 150 milliseconds to try and compute that in real time. You have 500 million behavioral data points. How do you do that? Okay, well, that turns out to be hard. The math, interestingly, is really easy. It's how do you get to and from the data really fast? So I needed a co-conspirator. This, you know, I put something together, but I needed extra help, and I happened to find Brian over there. So he and I kind of teamed up to work on that problem. And one day, you know, I was in fact outside smoking, and it had sort of occurred to me the night before that those were really related problems. The same database problems I was running into I had run into at Salesforce, like this thing keeps crashing, and hey, I need this really, really fast, but not necessarily relational data storage model for small transient objects. How about we like put those together? Because there's nothing that does anything like that. So I suckered Brian into it, I was lucky. Or he saw my brilliance. You can take it either way.
Which is it?
I was bored.
Entirely possible. The experience of entrepreneurship is an incredible ride. It is a roller coaster of the first order. It is the highest highs and the lowest lows. I would not, like, if you have an idea about you believe in, then you should go do it. It is that simple. Like, just go do it. With that being said, like, part of the process of entrepreneurship is building this thing from nothing, but what you're building is very much informed from where you came from. So try and keep like the lessons that you have learned in mind. Like even if there was someone you hated or something that just drove you nuts, at least remember like, oh, I really didn't like that, so I'm going to try not to do it again. Lots of people have given lots of advice about entrepreneurship. So I guess my real advice is, you know, if you feel that need, then you should just go do it. Go build something awesome.
Great. John?
If you have a lot of money to start with on your own, then you can put it into your own company. And you find out that, you know, hiring people and getting them to join up your vision is like the hard thing. And it's kind of a joke, but I've done 3 or 4 ad-related companies before, and they've been successful. And the thing about the ad business that's interesting is it's pretty much cash flow dominant, and you have to bootstrap to the point where you're big enough to make money so you can collect money, attract advertisers, and pay your publishers. If you can pay your publishers a little bit more than the other guys out there, you know, you'll all of a sudden have a rolling business. And so that's kind of been what we've done. I would say that ad tech in general is not a highly valued sector by most VCs. There's very few VCs that understand it. And so you will need to rely on your personality skills to kind of attract them and convince them that investing in ad tech is the way to go. But to apply it to kind of any industry, I would say, you know, what I think and what GP just said is, if you have a belief in what you're doing and you're good at attracting other people to share your vision, then get started and you can probably find some way to get going for a while. It's a lot more fun to try than it is to just wish you had done it and not do it.
Scott, how do you think about new businesses inside of your company? How have you seen the company evolve?
Well, we're running this new venture as trying to do it as a startup mode in a company 6,000 wide. You get salespeople that are out selling it ahead of you, and it's just like, oh, stop. Let us pick the customers, please. That's been our biggest problem after we did our announcement, PR announcements. We've got all these customers lined up that are current offline customers that want their data offline, and we're trying to like, okay, let's pick that one, and let's pick that one. But we're trying, with the new shift of CEO and our founders retiring, we've actually got into startup mentality. The group out here in Foster Cities and part of the people in Central Arkansas have been consolidated and isolated as much as possible from the corporate structure so that we can move fast.
Right.
And fail fast and keep going. So that's been my experience.
Great.
So I've been around this crazy train a few times. I've been a fourth employee, but I've never started a company, but I've been involved in a lot of rounds of funding. I spent a lot of time with VCs just because I think they're interesting people.
Any VCs here?
What I've found is, what I think I've gathered, and maybe you guys who've actually started companies can correct me, but it seems like they invest in spaces. The good ones don't invest in ideas at all. They invest in like a space and a team, and then occasionally momentum. So like, you know, if you created something in your basement and it's getting 1 million downloads a day, that's momentum. Even if the space isn't hot and they don't know who you are, you can probably still get funding. Or if you're a known quantity and you've executed before and they believe in you, I've seen people get investments literally with no idea. Like, hey, I'm going to start a company, and you know me, I've succeeded twice, you know, and that works too. But I mean, to highlight how unimportant the idea is to success, I mean, I had a conversation with a nice guy right before I came up here, and I lost his name in my head, but I have his card. And I was describing what MetaMarkets does about, you know, super fast ingestion, billions of events, highly predictable, open source database, amazing visualizations with pivot to, and he says, you know, that's what there's like 50 companies doing that. And I laughed. I said, yeah, you're right. That's what everybody says. And that's why you can't invest in just ideas, because every idea you have that you think is completely unique is probably like been had like 20 times. I mean, how many people tried to do Dropbox before Dropbox existed, right? It was the wrong timing, the wrong team, the wrong execution, whatever. But it's not a new novel idea. It's about having the guts, like you were saying, to go out and start it. It's about having someone who believes in you, and like you were saying, being able to instill confidence in a team and hire. You know, execution is king, and a hot space lifts all boats, as they say. Anyway, that was long-winded. Go ahead.
That's great.
Well, the first thing I would say is, if you go through that process, you will learn things about yourself that you had never thought you were going to learn, and perhaps don't really want to know about yourself.
Truth.
So it is an experience that will change you in ways, like people say about having children, right? There's life before it and life after it, and you are changed in ways you will never expect. So for that reason, if you are bored, like I was, starting a company is a great thing to do. You will not be bored for several years. What we did when we started the company, since we were execution guys and not really known to the VC industry, even though we had been at different starting phase companies, was rely on a proven execution. So the goal was to build a product, start selling it, have some revenue, have some proof points. And as you say, it's not really about the idea.
Right.
And so this was like a marginal technique, I would say. I was hoping it was the best strategy that I could come up with, the idea that if you had a product and people liked it, maybe you'd get investment. And that's because Couchbase was out there with no product, barely an idea, and they had VCs fighting to get in on the round. And we were like, they're a bunch of chumps. I'm sorry if there's anyone for Couchbase here, but you have your pride in your own product, right? And you have a competitor, so that's always how they look. And but they had a seasoned guy They had a story of being, having the guy who did Memcache, which actually wasn't true. And so they had money like crazy.
But it looked good.
It looked great. So part of the theory was to have some money that would allow us to feel when the market started happening. Because a lot of the companies I've been at, there's that moment when you actually start feeling it. You've got a product and people are starting to beat down your doors, and you go out to a place like this and people say, oh yeah, of course I need a fast database. What do you got? So the idea was to hold on until that started happening and then find that right moment. And luckily enough, being able to stay in the business, and my other co-founder Srini, VP of Engineering now, his plan is to make sure we actually stay in business. And he thinks that's the most important part of starting a company, which I can't disagree with either.
That's great. Great stories. So let's open it up to questions from the audience. Please go ahead, and we've got a mic over here if you want to say your name and your question.
I actually don't have a question. I was just wondering if you could just go over your names and your companies one more time before we started.
Please.
Brian Bulkowski, Aerospike.
Steve Harris, MetaMarkets.
Scott Jones, Acxiom.
I'm John Kristanak from App11.
GP, Brightroll.
Hi, I'm Brad Palmquist. I'm trying to figure out why everyone on the panel is either connected to Aerospike or using Aerospike. Is it a random selection and this shows your dominance in the space, or how did that happen?
The meetup was put together by Aerospike, and we invited a bunch of folks that are related to come talk about big data.
So for Aerospike, who do you see as your biggest competitors?
I would say that there's two families. One is, before products in NoSQL happened, as you've been hearing these stories, it's roll your own, right? Because you've got a very specific problem, you can go after it, you can create a database or a data storage layer that is exactly what you need. And I mean, that's what my business was before founding this company and before NoSQL started. There's still plenty of that around. What I see in the field a lot is quite a bit of Redis. I think Redis is a great product. It sort of takes over where Memcache left off. It has a rich object model. It has things like Lua UDFs. A lot of people love it, and it has a lot of great miles on it. What we see as the shortcoming is SSD support, which is to say Flash, and how they do their clustering. But I see a lot of folks. I was over talking to Weibo and some of the Chinese guys. They love Redis out there. They build these big 200-node Redis clusters all in memory, and that's how the big social networks in China work. So great set of products there. HBase on the slower side with a little more analytics, great product. For the ease of use, I mean, that's where you see Mongo that doesn't have the same scale characteristics, right? So we see a lot of stuff like that.
Hi, my name is Prasanna. I'm an entrepreneur working on my stealth startup. I found myself to be alone because when I looked at the big data, the first observation I had was the problem I was trying to solve was actually done by existing clusters. I'm a hardware guy. So my observation when I started looking around big data was most of the companies and the products were around software. And I didn't find hardware companies solving bus problem related to latencies, capacity problem related to the edge, and more importantly, processing problems for 100, 200, 300 nanoseconds. Any comments on if my observation is right, wrong, bullshit? No, it's not.
Please go ahead.
You picked a tough row to hoe. I agree that there are not a lot of hardware companies targeting that particular problem. The question that I think you need to ask is, what's the direction that the software, that the consumers of your product are heading, and how can you align a hardware product with those requirements? So ad tech, for example, it's in a little bit of a transition period now where a lot of advertising company traffic is coming from AWS. So if you're in any sort of cloud technology, any sort of hardware solution's off the table. Like just by default, it's off the table. Even if you were to do things like, okay, you have hardware and you're deployed as software as a service, direct connected into AWS, you're still imposing a, let's say 1 to 4 millisecond network penalty to get to you, at which point a 300 nanosecond optimization isn't maybe that interesting. On the other hand, as we move more towards a programmatic buying, I should ask real quick, what's your background in advertising?
Fairly, I can understand that.
Okay, cool. For maybe those who aren't following, historically, advertising is done sort of as an internal auction within the ad network. Increasingly, that's moving to a more programmatic thing where an ad exchange will get a request like, oh, here's a user who showed up, we want to show him an ad. We'll farm it out to a bunch of different associated people and say, do you want to bid on this? Yes, no. Collect the responses, run an auction amongst all of that, and then return the correct thing. So when that happens, you're really starting to get into the realm of optimizing for latency. Because if you can get down to, oh, I have an extra 2 milliseconds to answer this question, then you can make you might be able to make a different set of software engineering trade-offs in the ad decisioning platform to say, am I going to bid, no bid, how much am I willing to pay, how much data can I draw on from that? And as that happens, the technical background of AWS starts to work against you. Like virtualization overhead starts to be a pain, like just the unpredictability of AWS is starting to become an issue. And the ability of people to start drawing that into traditional data center environments and direct connect, direct single mode fiber to all of the people you could possibly be in that sort of real-time programmatic buying arrangement with, there you might have something.
Yeah, I would say make sure you know who your customer is. I mean, one of the, at least on the software side, a platform built for everyone is a platform built for no one. I mean, probably many of us have learned that the hard way, and maybe not. I don't know. I learned it the hard way. So, my guess, the people who care most about nanoseconds similar is financial markets. If you can find, and they spend tons of money, it's probably not a high volume play because most people don't care about nanoseconds just yet. But certainly a foreign exchange trader might, or someone dealing with derivatives. So the way I think with an idea like that, know your customer and go out and since it's a small group of people, it's either government and intelligence probably or financial is my guess, unless somebody can think of somebody else who cares about nanoseconds. Go see those people. Go talk to them and really understand what they're trying to accomplish so that you know what to optimize for. And potentially, if you can get them excited, then those are the people who will be willing to invest.
Yeah, so one of the problems you face, sort of the half of what GP said, was speed of light. It's going to get you every time. There's no way around it. I'm sorry. I'm not smart enough. You're not smart enough. So if you're going to make a decision and report to a machine outside of your own, that's where you're just kind of doomed, because optimizations on the nanosecond level just will be swamped by any speed of light delay between machines, except in a very, very few, very, very small subset of problems, unless you have problem domains beyond that. So I happened to talk to one of the guys who does this at a large financial services firm in New York, and they said, yeah, we do our own chips, and we don't even like ASICs. They're too slow. We have the best chip designers, and we do our own custom silicon, period. And that's a $10 billion a year investment, and we're happy to do it. So you're going to have to think about who's competing with them, and then you've got this light speed problem because there's only so many people who are as connected from a speed of light problem. So it's a tough road to hoe. Not to say don't do it. I mean, starting your own database company is about a similar level of insanity. So.
Scott, how much, and John, how much of what you're doing is in the cloud and using AWS versus in-house?
For us, we started out using AWS. It has, kind of upfront capital advantages. We find that for what we do, price performance on AWS is worse than managed or hosted. So we've moved a couple things. I mean, the latency thing and the RTB, the real-time bidding connection, meant we wanted to consolidate where we were. So we've moved more to managed hosting. But we look at AWS and EC2, and especially the spot instance market as really potential for good compute engine stuff. So if you're going to do Hadoop or something like Hadoop, and you can do it on AWS spot instances, you are probably getting a really good deal. You can do a lot of work that way, and that's currently our major usage of Amazon stuff.
We started with this development in AWS. The advantages on a dev startup is the capital outlay, and being able to throw away and say, no, I don't want that, I want this, and redesign your things as you go and be nimble and be able to pivot on that. Our analytics stuff, we are using spot instances on our Hadoop to calculate that. Most likely our analytics and our major batch data store is going to come back in-house, and we'll keep our edge processing either in AWS or in a colo. We're having some issues with AWS because they only have so many form factors, and our particular data set has a lot of entries, not a lot of data. So that means for particular an Aerospike, you need more memory, less solid state disk, because the indexes are in memory, the data is on the solid state disk. So we're having to spend more money on more nodes when we need, because they give you 2 terabytes and 64 meg of memory. And I need something kind of in between what they're doing. But it's a great place for startup. It's a great place to do development and get that and get everything kind of solidified, and then we can go and make that capital outlay saying we know exactly what we need.
Great. Other questions? Please, go ahead.
Hi, thanks. Frank McQuillan from VMware. I had a question. I'd be interested in the panel's commentary on SQL on Hadoop. We've been hearing a lot about that lately with Cloudera's Impala, with Hawk from Green Plum. So I'd be interested in your comments on what you're seeing and what your thoughts are on SQL on Hadoop.
I mean, it's been, I mean, Impala, SQL's been on, is it Pig or Hive that's SQL on Hadoop? Hive. I always mix those two up. I'm sorry. I mean, Hive has been around for a while. I know a lot of companies that use it. It works. It's fine. If you know SQL, it's slow as all get out. Is what I hear. I don't use it that much. And then Impala, I think has anyone? Is it even at one point is it out yet? I know it's
you can use
marketware.
There's
but
actually
okay.
there's a demo actually that
cool.
Cloudera has. You can actually do Impala queries. I think they're running on an AWS cluster. You can run this week if you go to the right place. We've looked at it extensively, and there's a wide range of options, and there's also projects like you mentioned one, but there's Tez, there's Stinger, Storm, Spark, and Shark, which are all kind of add-on layers to give you some version of SQL on top of Hadoop. It's still kind of comes down to what's your underlying storage layer. Is it HBase? Is it HDFS? What are you doing? And what I'd say is all of these products that we've looked at on Hadoop to do this, and evaluating these products is a big chunk of work that we do, are not mature. I mean, Impala is new. Right. Spark and Shark, things that make Hive 10 to 100 times faster, Impala is designed to do that. Tez is an Apache, Microsoft thing, Stinger as well, and also Twitter Storm. Those are things all designed to kind of change the computation diagram of MapReduce into something a little more flexible in terms of a graph, and be able to run the SQL components at all the kind of nodes out on the edge versus just kind of MapReduce, you kind of tree up into everything. None of these products are really kind of production level things. And so there are options out there that aren't necessarily on Hadoop that are, you mentioned Green Plum and others. There's things like InfoBright, InfinityB, there's MetaMarkets, obviously, Druid. And then there are, and there's Vertica, which I think HP owns, that at one level or another are more SQL compliant. So it depends what you're looking for. If you're looking to, hey, I have a bunch of unstructured data and I'd like to do SQL-like things on it, and I already have a Hadoop cluster with my data in it, then maybe one of these new things is worthwhile. If not, I'd say you can look at some of these more established. They come from the BI, OLAP world, or maybe OLTP world, and they might work better. And this point's one of the biggest things I think is one of the problems with big data is ETL is your lifeblood, and where do you put your data? Is it all already in S3? Well, then Redshift might be good for you. Is it on your own HDFS cluster? Well, then maybe one of these Storm or Impala is actually the thing to look at. Or do you have something else? And then maybe you can look at a different kind of solution. So, it's a serious question, and I think the interesting thing to me is when you have people that want to use SQL and you want to use a real good version of SQL, then you need to investigate a wide range of options, but where your data lives determines really what you can do after that.
Right, thanks. I guess one of the keys is there's such a huge number of people in enterprise. You guys are mostly ad tech, which tends to be more cutting edge. But think about Goldman Sachs, think about J.C. Penney. They've got a ton of people who know SQL, and they know it well. So now you've got this tons of data sitting in places like Hadoop, sitting in HDFS or in HBase, that they want to get at to make their business run better, to understand their customers or whatever better. So that was sort of the root of my question of this huge installed base of enterprises with people who know Hadoop, and how can those skills be used to further their business.
So I recently talked to one of those kind of shops, got some interesting queries from them, and the guy I was talking to said, our SQL is like the Guinness Book of World Records. We have individual queries that are this thick. They have 40-year investments in these sets of queries. And I don't think they're ever going to move them out of Oracle. I mean, it's not like SQL is SQL. They can't even change from one kind of SQL to another. So, I think my opinion is that there's a certain amount of we're stuck, and people have to go beyond and try new tools. Some of those will be cut down, stripped down versions of SQL. Some of them will be new tools in general. Because nobody is ever, some of the queries I've seen, nobody is ever going to run them unless they have the Oracle source code.
Great. Other questions?
Hi, my name is Uday. I'm an EIR at a local incubator, and I'm looking at different databases for an application that will they'll have at least one part will have real-time predictive analysis. And so I've been looking at Aerospike and at SAP HANA. I just wanted to see what you guys think about SAP HANA. Thank you.
What did he say? He was asking about SAP HANA versus Aerospike. I don't know. Terracotta, so MetaMarkets doesn't really compete, hasn't really run into...
Scott, you've used HANA, right?
Have you used it?
We did evaluations.
I know a lot of people have evaluated, but nobody who's deployed it, I was going to say.
Yeah, under NDA, that's all I can say.
Will you say your name again, and maybe the speakers will be happy to talk with you one-on-one about that.
My name is Uday Sandhar. Thank you.
Okay, great. All right, other questions? And we're running out of time, so we've got one there and one up front here.
I'm Piyush Gupta. My question is, what do you guys think of Cassandra, and what space does it play in?
We ran Cassandra for several months, and the biggest thing I think that differentiates, I don't know exactly what space it plays in. I think you have to really be dedicated to it to make it work well. And the biggest thing that differentiates from Aerospike, which is what we went to after we gave up on Cassandra, is consistency. So it's a P2P, kind of thing that has all the Java compaction stuff and garbage collection stuff that was referred to earlier. But I would be impressed with people who have the level of commitment to make it work across data center, replicate. One thing I will say is, cross data center replication is not solved by anybody very well right now. So, if that's what you really need, you need to go figure out what works for you. And maybe if you're Netflix and you have 17 system engineers and whatever devoted to Cassandra, it's the answer. But for us, we switched to Aerospike and had much more consistent performance, and that was the big selling point.
And I'll ditto that. It's about the performance and the predictability of the performance. When you're doing ads and you're trying to get things under 10 milliseconds, you're looking at the 95, 99 percentile performance. And below 95, it does great.
Comment quickly on the Netflix thing. So Netflix's entire internal technology model is based on stuff breaks all the time.
Chaos monkey.
The chaos monkey, the chaos gorilla. Like they have, in fact, an entire simian army waiting to break stuff. And Netflix fundamentally has very, the problem they're trying to solve, they have very low cost of failure. If you get data that's like an hour old, it's inconvenient, but no big deal. If you blow through an advertising frequency cap and you show someone 10 impressions of an ad when you're only supposed to show them 2, unfortunately, someone's going to pay for that, and it's probably you. So they, just by nature of the problem they're trying to solve, and some by the processes they've adopted, which are in many ways really good. I think there's a lot for the software engineering community as a whole to model there. They're kind of in a little bit of a special case. They're maybe more willing to tolerate soft failures than the rest of us.
So, by the way, Netflix uses Druid. But one of the things that makes cross data center a little bit easier that I've seen is databases that are essentially that don't support deletes or updates, like some of the Google BigQuery and some of the other, and to a certain extent Druid, like databases. It gets really, really, really hard to do it well when you support deletes and updates. But when you eliminate deletes and updates, which you can do, and if you look at SpannerDB, it essentially I don't think it does deletes and updates, and certainly Google BigQuery doesn't. It allows you to distribute these things and not have some of the really gnarly race conditions. You still have some race conditions, but some of the really gnarly race conditions go away. So you may want to, if you're concerned about multi-data center, you may want to try and think about some of the databases that have a essentially write-only. Obviously, there's reading, but no updating.
Spanner's not available.
That's true. It's only a paper, but it will.
And they had to rewrite TCP.
And they had to add an atomic clock. So you could use Druid instead.
Yeah, but cesium's really cool.
So we're about out of time. Before we wrap up, and I'm sorry, I know you had a question. Let's take that, and then I know all of you guys are hiring. So will you talk about some of the skills and people that you're looking for? Let's wrap up with your question and then talk about that.
Dimitri Dimov-Sling, briefly, can you explain your usage of Hadoop with spot instances, kind of more specifically? A few of you mentioned it. What do you mean exactly?
We're running nightly, daily, hourly jobs to consume what our edge nodes are producing, and we are just doing spot instances. We don't keep a Hadoop cluster up. We're just using it to turn through all of the 350 million records that we're doing today, which is in alpha that we collect today, churning through that to create our data set that's going to go in our analytics. So instead of paying for a Hadoop cluster that's up all the time, or for normal instances, we do spot instances, and it cut our price down.
Do you spin up off an image or something like right scale? Or
Yeah,
is it
we spin up however many nodes we need. There's different jobs that need different numbers of nodes. We pull our data off of S3, which is where it's staged, run all the MapReduce job, and then write the data back to S3, and it goes away.
Great. All right, so let's wrap up with again your companies and what you are maybe hiring for.
So our main hiring need right now is core engineering, and mostly that means C programmers. If you know C++, that's a minus.
You filter on that?
Well, no, there's some nice people who somehow learned it. It's okay. But a lot of core engineering. We're down in Mountain View.
Meta Markets. we have, since we're a full stack solution, we basically have needs everywhere, like I'm sure a lot of people do, but certainly in IT and ops, we have needs, sort of back-end people, the kinds of people who like to write a database, but our database is written in, and our ingestion engine is written, our database is written in Java, and our ingestion engine is mostly written in Scala. Front-end visualization stuff is a lot of D3, DVL, CoffeeScript. But I would say if I were to ask the CEO, our number one need is sort of data scientists and people who can do integrations and can sort of straddle the world of being super smart technically and understand and be able to talk to customers.
Great. We are actually holding an open house Friday for positions. We're hiring from Hadoop, big data Hadoop clients to transactional edge type engineers to UI front end developers. We've traditionally not had much of a front end because we're dealing with the batch stuff and the traditional, so that's an open area to grow within the company. And we're based out of the Foster Cities, where our office is in San Francisco.
We're AppLovin based in Palo Alto. We're looking for data scientists and what I'd call data wranglers, which are people that want to learn more and become data scientists but are still programmers. So people with math, CS, stats backgrounds who want to do machine learning, who want to do optimization algorithms, logistic regression type stuff. And we mostly, we're pretty language agnostic. We like Python, Java. We will take C++ programmers without any apologies. And, you know.
I'll send you a couple.
It's a really, you know, it's a great environment.
So Bright Roll Engineering is hiring across the board for pretty much everything. Front-end stuff tends to be written in a mixture of JavaScript and Ruby. Please don't ask me about that. I'm absolutely the back-end-ish corner of the world. Sort of the mid-tier stuff for us is mostly Java and Scala. Back-end, if it has a real-time sort of piece, core ad serving is all in C. In general, though, we hire smart people. We're not super language specific. We've kind of figured if you are a pretty good software engineer, you'll be able to pick up whatever language we have in short order.
Great. Well, let's give our panelists a warm round of applause.